Now that we've completed the roughing toolpaths with the 1/2" flat end mill, I can see that I have material left over underneath the chin and around the base. So what we'll do is we'll come in with a smaller flat end mill and we'll focus on just these areas. Inside a canvas, I'm going to the night roughing toolpaths with a 3/16 end mill. This page. The below images and instructions are to be used as reference while programming the left and right side secondary roughing toolpaths using a 3/16 flat end mill. We have an image of the toolpath manager. It has the 2 additional toolpaths added to it. There's some information that we can get from here. It's a 3/16 flat end mill. There will be 2 containment boundaries for these toolpaths. I'll scroll down, reference the images below to determine where the excess material is left from the previous toolpaths. Using the spline tool, draw in 2 boundaries around the areas where the previous tool couldn't reach. The Z location is located at the center of the part material. These boundaries will be used to control the movement of the 3/16 diameter flat end mill. This containment boundary will be used by both sets of roughing toolpaths as shown in the image below. So we have a few images to reference. Here is the part after the 1/2" flat end mill roughing toolpath. Here's what the finished part will look like. Here we have an overlay, or we can see the material that was left behind, and we can see these light blue splines drawn in, and they're focusing, or they capture the area where the excess material is still located. So I'm going to go into Mastercam. I'm going to go to my level manager. I'm going to create a new level and call it secondary machining boundary or remachining boundary. I'm going to look at it from a top view, and I'm going to draw in 2 splines that capture these areas. I'm set to a 2D construction plane, and I'm going to set my wireframe color to this light blue. I'm going to try and match what I'm seeing in the canvas page. From the wireframe tab, I'm using the spline tool. Now be careful, your auto cursor will lock on to things, so what I try to do is I try to avoid locking on to existing geometry. So I'll start here, and I'm going to create a window that captures this area. And if you see your cursor lock onto something, move it away and then select away from the areas that the cursor wants to lock onto. And then when you get close to completing the circle, it will lock onto the last point. That will close the spline. And if I tumble my view, you can see that it is a 2D spline. It's all on the same Z level. If it starts to move around, if you're locking onto things, it will turn into a 3-dimensional item. So I'll go back to the top view again. I'm now going to create that spline around this area. So go back to the spline tool. And once again, you can see how it's locking on things. So I'm going to double up the points right there. It doesn't need to be precise. And I'm going to try and keep it so that it's not too wild, like it's right here, it's trying to lock on to that. And you have to double up the points at the corners, otherwise it'll get a very extreme arc. So I'll just click there. That'll control the curvature. Here I'll lock onto the point, and that will complete the splines for the containment boundaries. I'll select OK. I'll go back to the project page, and we have the settings or the pages for the toolpath that we're going to use. We're going to use the OptiRough toolpath again. So I'll go back to Mastercam. I'll go to the toolpath tab, and in the 3D toolpath section I'm using OptiRough. For the model geometry, I'm going to select the entire part. So I'll select the Select Entities icon. I'm going to Windows select the part. You could have triple clicked, you could have done several ways. There are several ways to select a solid part or a solid model. I did a Windows select. It ignored the stock model, it ignored my boundaries. I'll select End Selection, and once again I have 82 entities. I'm leaving 20 thousandths on the walls and 20 thousandths on the floors. I'm now going to start referencing the pages on the project page and matching the settings according to what we see on the project page. So for the toolpath, it is a dynamic OptiRough roughing. For the model geometry, we selected the part, the solid model that represents the knight. For the tool control, we're going to use two boundaries, and we're going to allow the tool to travel to the center. The center line of the tool will be allowed to travel up to the containment boundary. So I have it set to center. So for boundary chains, containment boundaries, I'm going to use this spline and this spline. And I'll select OK. That will take care of all the settings for this page. Go to the tool. We're going to add a 3/16 flat end mill to our tool list. So select Library Tool. My filter is still active from the last time that we selected a tool, so I'll select the filter icon. I'm still looking for a flat end mill. This time I'm looking for one that's equal to 0.1875 or 3/16 of an inch. I'll select OK. There's one tool that matches that description. I'll double click on the tool and it should be added to my tool list as tool number 2. I'm getting this error again, or this warning. I'll select OK. I'll select 6061 aluminum. I'll select OK again. And it changed my SFM, but I'm going to edit the tool before I make any adjustments down here. So right click on the tool, select Edit Tool. On this page, I believe the default settings will work for us. Something we might want to be something we might want to be aware of is the length of cut. So what we would need to do is actually measure the length of cut of the tool that we have in our tool crib. I'm going to change this so that the length of cut is 3/4 of an inch. So I'm going to go to cutting length, but before I can change the cutter length, I need to change the shoulder length. So let's change the shoulder length to 1, and then the cutter length to 0.75. From here I'll go to next. The number of flutes I'll set to 3. And then I'm going to turn the coolant on at this level. That way the coolant will be turned on for all following tool paths that use this tool. I'll select Finish. Back to my tool page, I'm going to set the cutting speed to 400, not 4,400. I'm going to set my FPT equal to 1% of the tool diameter, so 0.1875 times 0.01. And then I'll set my plunge rate to half the calculated feed rate, so 45.84. Divide that by 2. And then I'm going to copy the tool name. And I'll reference the project page for the note. remachine left side. All caps, remachine left side. And that will complete all of the changes that we need to make to this page. From here, we're going to jump down to the stock. I'll reference the project page for the settings for the stock page. Previous operation, one other operation, and we have selected, or I'm going to select the stock model that reflects what the previous two toolpaths have done. So I'll select this stock model. This is telling Mastercam what the part looks like prior to this toolpath doing its machining. That'll take care of all the settings that I need to change on this page. Go to cut parameters. Let's set the step over distance to 15%. The step down, I've got it set at 21%, give or take. And the step over is a little bit greater here too, so let's use these settings. I'll call this 32, I'll call this 21, and then the minimum toolpath radius is 15. So 31, or 32, 22, something in that neighborhood. We're going to round up. Say 32, 22. I'll keep step up turned on. It's not activated here, but I'm going to actually activate it. So I'm going to have step up set to 10%. And then I'm going to have my minimum toolpath radius set to 15. So that'll take care of all of the changes that I need to make on this page. For steep shallow, I'm going to reference the project page. We're at 0 and 1.5. These values were carried over from the previous toolpath, so 1.5, this will be more than enough. The top of the part after roughing is no greater than, say, 1.2 at this time. So in reality, all I need to do is set this to 1.5 and we should be good. From here, I'll go to linking parameters, and I'm going to reference the linking parameters on the project page. We're using minimal vertical retract, a clearance plane of 2 inches, and then the back feed rate is set to 400. Minimal vertical retract, back feed rate set to 400. And match the other settings. I believe these are default settings. The only thing I'm actually changing will be or verifying that the clearance plane is the same. The part clearance is 0.15, minimum vertical retract is being used, and my back feed rate is set to 400. That should take care of all the settings on this page. And from here, we're going to double check the planes and make sure that everything's set to left face. So that checks out. I'll select OK. Mastercam is going to process the toolpath. And what it's going to do is going to focus on just these areas that we've defined with these splines. It's doing a lot of jumping around, so what's happening here is that it's machining by Z level. So it's going to one Z level, then it's jumping over here and machining the same Z level. I believe we can make this a little bit more efficient. If I go back into the settings, and where it says optimize step-ups, next closest, let's try that. So go back to cut parameters, next closest, select OK. It'll take a moment to regenerate or process the toolpath. This is a little bit better. It's going to focus on this side, and then, or it's going to focus on one area and then move over to the next. I believe that looks good. From here, I'm going to update my stock for verify. I'll go to simulator options. I'm going to use the stock model from the previous set of toolpaths. I'll select OK. I'm going to save my work. And now with just this toolpath selected, I'll run verify. Once we open verify, make sure that stop condition collision is activated. I'll select play. And I'm going to speed this up a little bit. Now, something I might want to consider, you see how it's machining here? I don't need it to machine there, so I could redraw the spline and tighten it up a little bit. Or I could change how the spline is affecting the toolpath. I could say keep inside. So that's something I might change. I think this looks all right. It's just taking a little bit longer than I would like it to. And you can go in and you can adjust the spline, and that will tell it to either cut a little bit further over here. I can see there's a little bit of material that I would probably want to remove. And then it's cutting an area that doesn't necessarily need to be cut. So later on I'll probably go in and readjust these splines. For now I'm going to leave it the way that it is. So from here I'm going to exit out of verify. And we need to create the toolpath for the other side. Let's go back to the project page. And I'm going to read this. It says the images above are for the secondary rough machining of the left side of the knife. The T-plane that is referenced for the above toolpath is left face T-plane. To do the secondary rough machine for the right side of the knife, copy the proven secondary rough left tool face toolpath and paste it after the original toolpath. Change the description in the common field of the toolpath page and change the T-plane as shown in the images below. So this is very similar to what we did with the 1/2 inch roughing tool. We're going to copy the toolpath, we're going to paste it below, we're going to change some items. We're going to change two things. We're going to change the description on the tool page, and we're going to change the tool plane and the construction plane to right face. So I'll go back to Mastercam. I'm going to select just this toolpath. Be very careful, select just this toolpath. You can see that the green check is on it. Right click, copy. The insertion arrow is at the very end of the toolpath group. On the insertion arrow, right click, paste. In the copied toolpath or the new toolpath, go to parameters, go up to tool, change the description from machine or remachine left face or left side to remachine right side. Then go down to the planes, and for the tool plane change that to right face, and then carry it over to the construction plane. So WCS is left face, tool plane is right face, and construction plane is right face. This will tell Mastercam to rotate the part 180 degrees so that it can machine the other side of the part. From here I'll select OK. It needs to regenerate. is basically a mirrored image of the toolpath. The geometry is the same, the part is symmetrical. I believe it looks good. So what I'll do in this case is I will shift select both of these toolpaths. I'll save my work. I'll open up Verify. Inside of Verify, make sure that Stop Condition Collision is still turned on. And then run it. I'm going to speed this up. And you can see it's removing the excess material that the 1/2" tool couldn't reach on the base. It's important that we do that because that would cause problems for the next tool that we're going to machine this part with. It then moves over to the other side. On the machine, what would happen is that the part would rotate 180 degrees. We've already verified that. We posted out the 2 1/2" diameter tool paths, and we can see the A rotation. It starts at A0. The left face coordinate system establishes A0, and then the right face is 180 degrees from the left face, so it's going to call a 180 in the program. And now if I zoom in, you can see that the tool was able to get underneath the chin, and it was able to machine the extra material along the base. So this is going to complete the roughing tool paths with the 3/16 flat end mill for the left and right side. We still need to come in here and remove some of the extra material between the ears. So at this time I'm going to exit out of Verify. I'm going to toggle off the visibility of those tool paths. I'm going to toggle off the visibility of the stock model from the 1/2" roughing tools. I no longer need to see these containment boundaries, so I'll go to my level manager and I'm going to turn off the visibility of the secondary remachining boundaries. You cannot turn off a active level, so I'll make the solid model level the active level, and then I'll make the secondary remachining boundaries or boundary invisible. I'll go back to the toolpath manager. We're going to generate a stock model that shows what these two toolpaths have done. To do that, insertion arrows at the very end of the toolpath group, go to the toolpath tab, stock model. I'll call this one remachine 3/16 or remachine with a 3/16 flat end mill. For the initial stock shape, what did the part look like prior to these tool paths? We have a stock model that shows us that, so I'm using the rough 1/2" tool stock model. And then what tool paths are doing the work? So go to source operation and then shift select or control select the two tool paths that are using the 3/16 flat end mill. From here I'll select OK. It'll take a moment to process. Still not done. So after we complete these two tool paths, we're going to come in and we're going to machine, we're going to rotate the rotary so that we can access the area between the ears. Once again, so now the stock model is visible. There's some issues with the calculation. That's zero thickness material. I'll probably go in and on my steep shallow tell it to go 5 thousandths below just to eliminate that problem. So these two tool paths have removed this material and this material. We're now going to use something very similar. We're going to actually copy and paste one of these tool paths and use it to clean up the area or the extra material that's between the ears. So from here, I'm going to save my work. And this will not be an issue, but if it is bothering you, go back to your steep shallow and tell it to go 5 thousandths below. You can do it on 1 and it will take care of that issue. So I made that change, and it's going to regenerate the toolpath, and it's also going to regenerate the stock model, and it should remove that little zero thickness piece of material that was visible on the stock model. That did not show up in Verify. It was just it's a Mastercam issue. There shouldn't have been any material left behind. So it's going to reprocess this, and then we'll see what the stock model looks like at that time. Oh, I didn't regenerate, so it still needs to be regenerated. I'll select it and regenerate all selected operations. This will probably take a moment. So it's done regenerating the stock model, and you can now see that that extra material has been removed. So if you were getting that problem, or if you were having that and it was an issue for you, go into the steep shallow of the right face toolpath and just tell it to go to the steep shallow and the maximum depth, increase it by 5 thousandths, go to Z minus or minus 0.005, and that should fix the problem. So from here, we're ready to move on to the tool paths where we remove the extra material between the ears.